All right, if you've ever even thought about prepping for a tech interview, you know this one. We're about to tackle reversing a linked list. This isn't just another problem. It's a rite of passage, and honestly, it's the key to understanding a whole bunch of other list-based challenges.
And I'm not kidding when I say this is a classic. The frequency that this question comes up in interviews is, well, it's high, very high. Why? Because it's the perfect bite-sized test of whether you can really handle pointers with the precision they demand.
So, what's the big deal? It sounds simple, right? Just flip the order. But the real challenge, the part that trips people up, is carefully manipulating those next pointers without accidentally dropping the rest of your list into the void. This whole thing is an exercise in pure pointer discipline.
Okay, so here's our game plan. First, we'll nail down what the problem is actually asking. Then, we'll visualize it, which is super important. We'll explore the two main ways to solve it, the iterative and the recursive approaches. After that, we'll cover the common traps to avoid, and finally, we'll give you the final verdict on which one you should probably reach for in an interview.
So let's jump right in. What are we really trying to accomplish here?
Now, the key word here, the one you absolutely cannot forget, is in place. This means we are not allowed to just create a brand new list in reverse order. No. We have to perform surgery on the original list, carefully changing each node's next pointer to point backward instead of forward. Before we write a single line of code, let's build a mental model. This is huge for understanding what's going on. Think of a linked list like a train. Each node is a train car, and that next pointer, that's the coupling that connects one car to the next.
Okay, stick with me on this train analogy. Here's how it plays out. Our train starts off moving forward, one car linked to the next. To reverse it, we go to the very first car. We uncouple it from the second one, and we turn its front coupling around to point backward, to nothing. Then we move to the second car, uncouple it, and connect its front coupling to the back of the first car. We just repeat this car by car until the very last car is now our new engine.
All right, time for our first approach. This is the iterative solution, and I like to call it the craftsman's way. It's methodical, it's reliable, and it just gets the job done, one careful step at a time.
The whole idea here is super straightforward. We're just going to walk down the list, one node at a time, from the head to the tail. At each stop, we'll do our little pointer shuffle, and then we'll move on to the next. There's no fancy recursion, no magic, just meticulous, step-by-step work.
So, how do we do it? Well, the whole trick relies on juggling 3 pointers. One for the previous node, one for the current node, and one to temporarily save the next node. It's this little 4-step dance we do in a loop. First, you have to save the next node, or you'll lose the rest of your list. Second, you reverse the current node's pointer to point back to prev. And finally, you just scooch prev and cur one step down the line. That's it. Repeat till you're done. And what do we get for all that work? Time-wise, it's O of n. No surprise there. We have to touch every node once. But the real showstopper? The space complexity. It's O of 1. That means constant space. It doesn't matter if the list has 10 nodes or 10 million. We only ever need those 3 pointers. That is incredibly efficient.
Okay, let's switch gears. Path number 2, the recursive solution. If the iterative way was the craftsman, this is the thinker's way. It's elegant, it's a bit more abstract, but wow, is it a cool way to think about the problem?
The philosophy here is what I like to call wishful thinking. It basically says, look, I don't know how to reverse this whole big list, but what if I assume I have a magic function that can reverse the rest of the list for me? If I can make that assumption, my only job is to figure out how to attach my single current node to the very end of that already reversed tail. So let's break that down. The function keeps calling itself, digging deeper and deeper down the list until it hits the very last node. That's our base case. Then, as the function calls start returning, as they come back up the chain, that's where the magic happens. We do 2 things. We make the next node point back to our current node. And then, and this part is so important, we have to cut the old forward-pointing link. If you forget that, you get a cycle, and that's a bad day. Okay, so performance. Time-wise, it's still ON. We're still visiting every node. But here's the catch, and it's a big one. The space complexity is also ON. Why? Because every single one of those recursive calls takes up a little bit of memory on what's called the call stack. So for a list with n nodes, the stack gets n levels deep. That is the crucial trade-off, right there.
Okay, knowing the 2 solutions is one thing, but actually coding one of them up, under pressure, without making a silly mistake? That's a whole other story. Let's talk about the common traps that even smart people fall into all the time.
First, losing the list. This is the #1 rookie mistake with the iterative solution. You get excited, you repoint cur.next too early, and poof, the rest of your list is just gone, lost in memory forever. Second, creating a cycle. You do all this beautiful work, but you forget that the original head is now the new tail, and a tail has to point to none. Forget that, and you just made an infinite loop. Also, don't fall into the trap of thinking recursion is free. Remember that call stack? It's O of n space in most languages. And finally, on a practical note, recursion can literally crash if the list is too long because you'll run out of stack space.
Okay, the moment of truth. You're in the interview, you've brilliantly explained both methods, and then the interviewer leans in and asks, so, which one would you actually use in production code? It's time for the final verdict.
When you put them side by side, the choice for most real-world scenarios becomes pretty clear. The iterative solution is the workhorse. That O1 space complexity is just unbeatable, and you never have to worry about it crashing on a long list. The recursive solution, it's beautiful, for sure. It's a great way to show you understand a different paradigm, especially if you know for a fact the list is always going to be small.
And this right here is your money line. If you want to sound like a pro, this is the sentence to remember. It clearly and professionally justifies your choice. It shows you're not just a coder who can solve a puzzle, you're an engineer who thinks about real-world trade-offs like efficiency and safety.
So you've totally nailed reversing a linked list. Awesome. But in the world of interviews, mastering one problem just unlocks the next level. A super common follow-up is this. Can you reverse the list, but not all at once, in chunks, in groups of size k? How would you adapt what you've just learned to solve that? That's your next challenge.